Next is Gantt charts. Gantt charts is also a monitoring tool, but it can also be used as a scheduling aid. It keeps track of how much capacity is available in each machine, and because it keeps track of the available capacity, it can be used to load new jobs into the machine. So load chart shows the loading and idle times for departments and machines. So it displays the relative workloads over time. So x-axis is time. So schedule chart. So there are two kinds of Gantt charts. So that's load chart is the first one, which is made from the machine's perspective, how much capacity is available and how much capacity is being already used up and what is the remaining capacity. The second kind of Gantt chart is called schedule chart, and schedule chart is for a job. It's not for a machine. So for a given job, what are the different production processes and when it is supposed to start a given process and when it is supposed to end and when the next process should begin and so on, and the plan versus the reality, actually whether the job is progressing according to plan. So these kinds of details are charted with x-axis being time, and that's called schedule chart. Schedule chart monitors the job in process. So all Gantt charts are needed to be updated frequently, both the load chart as well as the schedule chart. So here is an example of Gantt load chart where we have days as columns and then work centers, and we have job loadings, and then these are the available time slots where new jobs can fit in, and this is when this work center is not available, maybe because of maintenance, things like that. Here is another example of Gantt load chart where this is a more detailed chart where this is done one for each machine. The previous example was a more comprehensive chart where you have all the work centers listed and days listed as the column. So because it captures the entire entire production shop, it is not minute enough. Whereas this one is one for each work center, so it gives you information in a more micro level fashion. So new jobs can be fit in more precisely. So we have time of the day going this way and day of the week going that way. So jobs can then be fit where as they come in, as they are planned to come in, you can make the bookings of the work center capacity. Now here is a schedule chart example. The previous two examples were load chart from the perspective of the machine, whereas this one is a schedule chart from the perspective of the job. So job A, okay, you're supposed to start in day 1 and finish in day 6. Job B and job C, and we can make this even more detailed, one for each job, with each row being a particular production step or production process for that job. So this one is more macro level schedule chart, and here is the ruler that indicates the current time. So as we pass through time, the ruler for current time will move to the right, or maybe the days will move to the left, the current time will stay put. Now this is the start. So here are the legend for how to read the Gantt chart. So this is the start of the activities, this is the end of the activities. The solid bar gives you the actual progress of the job, and this is non-production time, so like maintenance and things like that. Now assignment method is a way of assigning jobs to machines. So you have, say, 5 jobs and you have 5 machines. Now each job can be done in any one of the 5 machines, but the resources needed are different. Then we want to assign these jobs to those machines in such a way that the resources needed are minimum, or cost is minimum, or the flow time is minimum. So the objective is to minimize cost or time, and we can use the linear programming approach for this, and only one job is assigned to one machine, and each job can be assigned to any machine but assigned to only one. Now your textbook describes an elaborate method of drawing lines through rows and columns, and that's too complicated methodology, and it can only be used for small problems that we can do in class. But if we take this problem and model it as a solver problem, and the modeling process is very, very simple, then you can really open it up to any size assignment problem. You can have 100 jobs and 100 projects, 100 machines, doesn't matter. You can quickly run the solver model and find the best possible solution. So here is an example, and this is how the solver model will be set up, and now let me illustrate how to do this.